It's 2:00 now, and we are live. I am Stephanie Brown from Intelligent Construction Opportunities. I host this live stream as a way for construction professionals to gain insights about the technologies that support their construction projects today. Intelligent Construction Opportunities specifically helps contractors and trade partners and other construction professionals to decide on the technologies that are right for their projects. We specifically want to ensure that your construction technology integrates with each software platform that you and your tradespeople are using, so you can depend on the data outputs that you're looking from project to project. I want to introduce our guest today. Our guest is Corey Coleman. He's the Director of Education and Virtual Design and Build with Piquette and Howard. Corey started out as a draftsman, and his skills in related technologies include Revit, which is a building information modeling software for architects, engineers, and designers and contractors. And the purpose of our live stream today is to get into the technologies related to and how Corey and his team as Director of VDC and Education apply these kinds of technologies. So appreciate your time today, Corey.
Yeah, thank you for having me.
Fantastic. If you can share a little bit about your background and tell the audience, how you got to be where you are today with Piquette and Howard, that would be a great place to start.
Yeah, so growing up, my dad is a finished carpenter, so I was always downstairs helping him in the wood shop doing different tasks, building staircases and railings and everything when I was young. So when I got to high school, we had a CTE department, which allowed me to explore drafting, more of the architectural side of it. And from there, I got a degree in drafting from the CTE program. I left there. I went to Fitchburg State and started to look more into architecture. I got a degree from there, a bachelor's of science in architecture. And then I went on to Boston University, and I just got my master's this past January in city planning. So I've always had an idea of designing, modeling from a young age, and I've just kind of followed that path.
Very good. So I'm curious, when you were in high school, did you know that you were going to go on to more formal education, or were you just kind of feeling your way at that point?
I had really no idea of what it would take to kind of be an architect or what, followed this kind of degree. I had an idea that I wanted to draft houses. That was really my idea. My dad built houses. I thought it'd be cool to design for him. And that's really where it kind of stopped. I had no idea what would happen after high school, after I got this drafting degree. I thought it was pretty much you draw houses, you draw the construction of them, and that's all a drafting degree will suffice for. Fast forward to now where you can build complete buildings in virtual reality and walk through them using goggles, which I would have no idea that existed back then. I just used 2D lines in AutoCAD when I first started.
Wow. And you were able to be taught AutoCAD when you were in your CTE program?
Yep. We learned AutoCAD. We actually learned hand drafting, which I recommended keeping as a skill. It's taught me valuable first-time lessons of if you don't do it right, it's better to do it the first time correctly versus going back and fixing it. So I learned hand drafting. I learned AutoCAD. We dabbled in Inventor and SolidWorks for a little bit. We had a machine shop next door, which we drew gears and different components for. So a little bit of everything in the drafting department.
Wow. And do you find that if you have a talent for drafting, you're more adaptable in the kind of role that,
More, I mean, a lot. I have a bunch of different friends who have different skills and talents than me. More or less, it just comes down to a fine attention to detail, and liking to see things come together at the end of the day. Mostly anybody can learn drafting. It's not a high barrier skill. It's very, very elementary entry level stuff. But as you advance to different levels of the construction industry, you can add adeptness and mastery to it, to different types of modeling, pipe runs, all the way up to skyscrapers. So whatever level you feel comfortable at, there's probably a level for you in the industry.
So now, as the Director of Education and VDC at Piquette and Howard, maybe you can tell us a little bit about, how you got this role and how Piquette and Howard has invested in their own training program and what's involved there, Corey.
Yeah, so when I was at Fitchburg State, I actually was doing 2 degrees. I was actually doing architecture and then also pretty much vocational education training as well. I stepped back from that, but my boss wanted to start a school because he wasn't seeing the quality of candidates coming out of the typical traditional 4-year classroom apprenticeships they pretty much weren't equipping the candidates. We wanted to meet the standards set by our clients. So to bridge this gap, we took matters into our own hands and developed a unique classroom curriculum that goes beyond the standard book learning. Our program combines theoretical knowledge with practical application through immersive lab experiences. This anchors the theory that we teach them to real world scenarios and ensures that the apprentice grasps the concept thoroughly and that they can apply them effectively in the field. What sets us apart is our dedication to providing this lab experience by giving our very best kind of field instructors the chance to teach our apprentices. For instance, our first year apprentices, usually they're brand new green at a high school. They've either never held a drill before or have very little practical experience. But we bring in our best pipe bender in the company and teach them the art of safe and skillful pipe bending. So pretty much at the end of the day, it eliminates the risk of acquiring outdated, incorrect techniques in the field, and that our apprentices receive a solid foundation from which they can build and expand their skills.
And when you take on these students, how are you building in the virtual design into their learning and how they're, absorbing this information?
Yeah, so pretty much our idea is third year that's when you come out of your shell of being just a kind of a new apprentice, and where you're actually understanding the industry, understanding what's required of you. And I bring in and I start teaching them doing, Bluebeam trainings. I have them look at some plans, some 3D designs in Navisworks. I run them through a class. We also have them review the models, and we're going to be doing takeoffs through 3D models so that they can walk through, check the cable tray, look at how many hangers they need, count up that stuff, so they can kind of get acquainted to the new 3D technology coming in the field. And then from there, I give them the opportunities to come do additional trainings that we host, such as Trimble trainings, Navisworks trainings. Any different type of training that we host in the company is open to anybody. And it's just an additional training if you're interested. So there's many opportunities to further your education based on what you like, what you don't like.
And can you do a little bit of a deeper dive, perhaps, into what Trimble is, what Revit is, what Bluebeam is, for our audience, so that we sort of round out, the understanding of those applications?
Sure. So I'll start with Bluebeam. Bluebeam is a advanced PDF viewer. It's pretty much the premier one in the industry right now. You can pretty much call it CAD Lite in a sense. It's able to mark up PDFs, do takeoffs from it, estimations. It's become a very useful tool for our PMs to gauge, projects. You can check changes in documents really easily. You can send out an invite to have everyone mark up one PDF in the same view, so you can actually see real time what changes are happening, and it tracks all the changes. So we use that as our premier kind of conversation or comment tool. Revit is an authoring software, which allows you pretty much to draw any scope you want in 3D. It originally started as an architecture program and then took off as an MEP one as well. MEPs are a little bit slower to adapt to it, but it's becoming a more powerful software to use. More or less, it's what you would use to draw your conduits, your lights, any receptacles. You can do anything in the program that has to do with the scope of a building. And then I believe it was Navisworks is the last one you mentioned. Navisworks is just a viewer tool that you compile all of the models that you would take from, let's say, Revit, CAD files, and then you're able to throw them together into one view, so you can actually walk around and look at the model as if you were walking in 3D. Look at different aspects of the building, its ratio, see any problems ahead of time. If this pipe is running through the ductwork, if this light is hanging too low, different types of elements. But it takes a bunch of different files and adds them together, so you're able to view the project as one single source.
Can you say from a skilled trades perspective, who kind of cottons on to these technologies better, worse, or perhaps, has a more of a challenge wanting to use them as applications?
Yeah, are you talking about specific individuals, kind of like what they're
job roles or positions? Yes.
Yeah. I mean, from what I've seen and some of like the colleagues I've talked to, the younger generation really latches onto this really easily. Anyone who has kind of video game experience, in my sense, it has a much easier time adapting to the 3D environment. And then it's people who don't, use the computer too often have a little bit harder of a time grasping it. It's all Windows-based type platforms. So if you are, I would say adept at, Microsoft Word, Outlook, stuff like that, any Windows programs, you're able to use these programs efficiently, not mastered, but to the point where it's useful. So anyone who has basic computer skills can usually get by and use these softwares.
Very good. Very good. I mean, you would imagine that it would be people that have literally grown up with computers at this point in time.
It helps a lot to ease the curve. But if you've been using computers for a while now, you can get there. It's not impossible. It's just your efficiency using the program will probably not match someone who's used computers their entire lives, like the younger generation.
I didn't ask you this. How long has the PNH's university been up and running?
We are running into our third year now. So we are doing a 4-year apprenticeship program. Our third years are, we have 29 of them right now. So we're doing really well. And they are pretty much exceeding all expectations from the field. What we hear from our foreman is that the apprentices that are going through the university are outpacing the typical apprentice or even some of the journeymen that we see out in the field. The idea is that we take pretty much all the curriculum that they need and we pack it together, but we make sure that it's grounded in theory so it sticks a little bit better. And they pretty much what we see is that the camaraderie from our school helps kind of build that relationship with the apprentice. They understand that they are part of a company. They can ask questions. They can actually go out and fail and not, be fearful of repercussions because they're failing. They can actually ask their teammate who's actually in class with them, why didn't this work? What should I be doing better? And then they can always ask our teaching staff. Our lead instructor, Jimmy Cole, loves to talk about theory, and he'll tutor you till he's blue in the face about theory. And that's the idea here, is that everyone in PNH is here to help you succeed. You're part of our team, and if you're failing, then we're failing.
So it's a pretty young program, but it certainly looks like it's got tremendous potential if there's 29 people going through it already.
Right.
Go ahead. No, go ahead. That's fine.
I was gonna say, we just we're rounding out our next apprenticeship program and our next year of the program, and we're going to be about at 60 apprentices for the entire program, maybe 65.
And do you see any lights here where these graduates look like from management material, or is it way too soon to see that anybody's got that kind of?
Oh, we've actually already identified probably like five or six different people who will be foremen, either right out of the gate or in the future, along with pretty much most of the classes. I would say a majority of the class is able to run some sort of either smaller project within a main project, or take on specific efficiency tasks and stuff like that, and be leaders in the field.
So can you give an example of what kind of a project that would be? And again, I want to kind of stay on topic here with the virtual design.
So obviously within the main project, we would just have branch feeders or all the underground per se. The apprentice would be tasked to make sure that all the underground for the project was laid out, that all of our points were hit, and then everything was successfully done, so that the foreman can worry about the entire project as a whole, and he can kind of compartmentalize that to another employee or delegate it to him. So
very good. 5. That's fantastic. Like that you can identify that many. I think that's terrific.
Yeah, we're excited. So
as you should be. So as far as virtual design and construction is as a concept, I just want to sort of stick on this for just a minute, just so our audience can see the wide applications of it and the job roles that it affects.
Yep.
So the whole idea, maybe we can talk a little bit about what the difference is between virtual design and construction, and how people define BIM. Can you talk a little bit about that, Corey?
Yeah. So when I first started, I am guilty of this, but I used BIM and VDC interchangeably. BIM was kind of like the first label that came around when Revit came out, and this whole idea of building information modeling came about. That's how I learned about it. But it's two very distinct, different concepts that are kind of interchanged with wording. I mean, people will still say it for a while, but the idea of that is BIM is creating a digital representation of a building's physical and functional characteristics. So such as where all the pipes are, what size pipe this is, what kind of pressure is that pipe holding, this panel's name, this panel's electrical load, has all the information of the building, right? And you'll hear the term called digital twin a lot now. That's becoming like the buzzword in the industry, but it's pretty true. It's just all the virtual information is now housed into this 3D model of BIM, so building information model, right? VDC is kind of like a step back, and it primarily focuses on the broader scope, such as project management, specifications, planning, scheduling, coordination, and how the actual building gets built together. So it's a construction base, but it's virtual. So more or less you use VDC to solve the problems of use VDC to solve the problems of the physical world, and then BIM is pretty much the end result of the VDC process.
More the application of the process, yes?
Yep. Yeah. You could say that.
Now I think it's important. I mean, as you said, you brought up digital twins. I mean, we fling these buzzwords around, and I don't think sometimes we stop long enough to really understand the concept. So I think it's really important, because these are humongous ideas that touch upon such amount of detail and complexity when it comes to any kind of a building project.
Yeah,
that's the whole point.
I think the concept is taking off because of the simplicity of all the information in one location. You don't have to keep 50 different drawing sets of your old building to understand, what size feeder is feeding this electrical panel. You can go right into one source model and find that out, and then see where the pipe is actually leading in 3 dimensions, instead of trying to trace it out by hand, or by, having someone walk the pipe run to see where it goes.
Well, and so to your point here with your benefits of virtual design and construction, I mean, the collaboration factor, is there any point here that really sticks out as something that, what a difference now? I would imagine risk management and safety is a huge factor, because all this takes place in the pre-construction stages. I mean, that's the point.
Let's see. I mean, first off, it's just like the improved collaboration. VDC has really kind of changed the way that you can go about building projects in general, or even building the building. It's really adapted itself to allow for like huge prefabrication efforts where that if this pipe run is going to be installed later on, I can build this panel in a whole skid type setup and ship it to the site versus building it stick frame on site and waiting for stuff to be built around it. Let's see. I'm trying to read it. It's a little bit. Just the clash detection is another huge issue that you would run into in the field. Basically, you would have to sit down. From what I've heard, is you sit down in a meeting with all the plans laid out, and the plumber would be talking about where his pipe run is, and then you would have to old school say, "Oh, I'm going to go there and figure out where the route goes." Now we can do that months ahead of time. Make sure that the pipe run is efficient for both parties, and that it will actually meet the system and give expansion room, allowing the guys in the field to focus on building it instead of trying to figure out how to piece it together. They can focus on just piecing the actual process together and not worry about hitting A and B or missing scope.
And then for sure that's applicable with supply chain issues now. And you talk about specifically the clash detection, which is why I'm glad we clarified the difference between BIM and I'll say the overarching scope of virtual design and construction, of which BIM is a part of.
Yeah, pretty much at the end of the day is when the VDC is done, you can turn over to the client a really good representation of what they have. And from some of the clients that we see, especially facilities, industrial manufacturing, they want to know where does this panel live? If I have to go, or even like where this pump lives, if I have to go replace this pump, where is this information? What size is it? What voltage it is? They can actually just go through the model and click on it, and it should give them all the relevant information of that pump. So their maintenance team doesn't have to go search through 50-year-old drawings to see what they need to reorder. It's right there in the model. It's easy for them to see what they need to change.
And I'm curious, what percentage of Piquette and Howard are self-performing in-house staff versus subcontractors? Because I think this information is very relevant to subcontractors, because sometimes I think that they sit outside of the what's in it for me kind of idea.
Yeah, so P&H is an electrical subcontractor ourselves. Mostly what we do pretty much everything in-house. We've been expanding. We do all our power side. We do our lighting controls. Specific, I believe lighting protection is usually the only thing we sub out because it's very specified, and we don't have the training yet, but we've just expanded to a data portion of our company. But with subs themselves, I'll just take maybe a smaller subcontractor who does maybe just tile work or something like that. You're able to take this model instead of doing like a hand count or stuff like that. You're able to use maybe Bluebeam or Revit to really pull like square footages out of the program really quickly. And at that point, moving one step further within Revit is if you give it parameters and you write a little bit of background settings for it. You tell it for this room I want X amount of square feet in tile. It will actually produce tile counts. Revit's very powerful, and if you give it a little bit of information, it's able to produce quantity takeoffs, amount of tile, amount of grout, amount of even little rubber spacers that you would need based on the amount of tiles and space you had if you wrote the correct parameters into it. So if you have a little bit of time and put the upfront effort in, it will pay like kind of tenfold down the line, especially for smaller subcontractors. It doesn't have to be a huge engineering department. It could just be someone in Bluebeam using the tool efficiently along with maybe like Excel or something like that.
Now, when you start working with your subcontractors, are you the ones saying, okay, download this app and we can use it in this context?
Usually the subs are allowed to do however they want. They know their efficiencies. Just in-house, what we do is based on a standard that we provide.
So, but when you work with a subcontractor, I would imagine you're trying to use the same software is what I'm getting at.
Yeah,
Yeah.
in a sense, if we can cross collaborate or figure out a way to get the information. A good part is a lot of information nowadays. A lot of software understands that it needs to talk to each other. So you can probably grab a CSV format of something, or a specific format that would integrate to your software in some form or fashion.
And I just want to make sure that our audience I always like to contextualize these conversations. So you and I talked about a bit of a case study here. So if you can just sort of set up what you did with the Project Maverick, and obviously we can see on screen that you use Revit and you use Trimble and you use this tech that we have not talked about, which is an add-on.
Yep.
And if you can just sort of extrapolate a little bit on this particular case study, and then we'll show some visuals.
Yeah. So Project Maverick was a biomedical lab office building that we were added on to help design assist. And in that fashion, we were brought on board because of our knowledge of the type of clean rooms and stuff like that we do typically. And we were there to help the engineer decide what to build, because we had the experience of like, oh, this will work. This takes a long lead time. These products work for us. This is how we approached this problem the last time. So what it did was it helped us kind of work ahead of the construction, where you typically, in a typical, engineer plan document setting, you would get the plans and then you would try to remodel the 3D model to make it more efficient. We were able to go right from the beginning of the design and make our runs efficient, make prefab skids, do a lot of our prefabrication up front, so that when it came time to build it, we were ready to go and just kind of be putting stuff into the building right away with a tighter schedule.
Very good. Yeah.
So
imagine the time and money and aggravation that if you use these tools and apply them where they're supposed to be applied, they make such a difference to the end result.
Yeah, I couldn't imagine that this project would be where it is if we didn't do VDC. The mezzanine that we were dealing with was very tight. It was like 8 feet of clearance, which is very small. It was a pre-built mezzanine, so we couldn't change it. So we worked tirelessly with the mechanical contractor to make sure that our runs were, and the model is exactly what we needed, so we could avoid each other. And the best part is, like, they were willing to work with us. If we had to get a conduit run through somewhere, they were willing to, jog their pipes over us. And it helped not only them, but us complete the project as a team instead of everyone kind of fending for themselves. And good luck. You still have to get your stuff in. That didn't happen on this project, luckily.
So as we're seeing here on the left-hand side in the slide, we're seeing the model, the BIM model, right?
Yep. So
these are the realities of that model.
Yeah. So the slide on the left is the main electric room. It consisted of two switchboards and then two, I believe they were 4,000 amp ATS systems. And what this whole portion of was the facility, since it's biomedical, they wanted to have a lot of backup power. So they were buying two 1.5 megawatt generators. And these things are the size of tractor trailers. They're 50 feet long, 20 feet wide. They're huge. And so this drawing on the left represents the Revit model of what I drew in 3D. We were able to take that information because it's built one-to-one, and bring it down to our prefab shop, where I was able to have our shop build all the underground skids for each individual pop-up into the underground of the substation, the ATS, the switchboards. And we were able to build those all ahead of time and ship all those skids to the site. So all the guys in the field had to do was just drop it into the ground. They had to worry about, just the rigging, but they didn't have to worry about staying in the trench, collapsing, all the safety issues that came that way. And what we did was we used the Trimble to lay out the box out points ahead of time. So we went out there, we took flag stakes, and we stuck them in all the corners of the box out so that the conduits can shift left to right just a little bit, because you're never going to be 100% accurate. But we knew that if you were in this box, that's where the switch here was going to live in 8 months. So right above you, that's where the board should land if all the construction goes appropriately. And the biggest thing is that these generators that we were doing, they were like 46 weeks out, something like that. And you're trying to hit and get 8 conduits into, if you look at that bottom right image right there, into pretty much just a 2 foot by 1 foot box in the middle of nowhere. You're not in the building, you're way outside the building on the ground. And so we use the Trimble to tell us exactly where these points were, so that when these generators landed, they were next to each other. So there was no room left or right. They had to be touching. That when these set onto the pad, that these conduits are going to pop up in the generators exactly where they need to be. There'll be no, jackhammering, no rework or anything like that. And you can see how tight that little box out was. We nailed the entryway for those 8 conduits. Yeah, it's about 10 actually with the auxiliary conduits for each generator. 10 months out from what it was, just by placing these prefab skids and landing inside those little box outs. If not, it would have took weeks to go back and try to redo the pad, make those conduits fit just where those generators were. Not to mention rehiring the picking crew, the crane, everything like that.
Well, I think you've given a really nice picture, at least a broad overarching scope of how virtual design and construction works, overarching scope, application, etc. I just want to wrap up today by asking you, what technologies are you seeing, like, just coming on the edge right now, that you see that'll mesh in with these concepts and perhaps blow up in their own right? And I'm thinking digital twins, certainly VR. What are you seeing? What do you feel is happening right now?
So, just being like working in P&H for, the past 6 years or so, just seeing the need for 3D modeling. A lot of our contracts require some sort of 3D modeling on, our side to make sure it works. So it's becoming more and more required in the industry to make sure that, you can meet schedule, you hit building. It just gives reassurance to investors that too, on the higher end of who's funding the projects. And from that, VDC it's probably never going away. It's only going to be more and more required to do in every single project. And from there, it's going to be, ease of use. Like, how are you going to make it easier to use VDC on the site, right? And Trimble is one of those companies who's kind of trying to make it easier. So instead of you looking through a computer at the 3D model, you can bring a tablet out to the site and use a tablet on an app instead to see where it is. You can use augmented reality, where you put on a set of glasses or goggles and able to see the ductwork where it needs to be in the field. You can bring it to your prefab shop and see the skid built in front of you, so you can quality control the process instead. And then I think from the other point is that, AI is probably going to play some sort of role in the process in the future, where clash detection takes a lot of time. It takes a lot of people sitting in a room trying to figure it out, this pipe goes here. There's an add-on somewhere that I saw that AI can draw a conduit run for you and avoid these things. So it can get you 90% of the way there, and then you would take the last 10% and use the human element to kind of fix and manipulate it. So using AI to do a little bit of that, monotonous heavy lifting, and then using, your skills to finish off the rest of what it would actually be in physical reality.
I just have one sort of add-on question: that which vendors are you seeing really wrapping their arms around the AI factor? It's everywhere. It doesn't matter what industry you're in. The whatever trade press is talking about AI. It's everywhere. So which vendors do you see right now as the forerunners in AI?
Not particularly sure. I know that obviously Autodesk is probably going to be, reaching out and trying to do that. Like I said, clash detection does take a lot of time, a lot of effort. And if there's a way for AI to do that and report out to you, I know right now, if you use some of their products, it can generate a clash report really, really well, reduce the nuance reports, such as minuscule clashes against, let's say, a millimeter of insulation on a pipe. It can remove those nuances pretty well from what it is for just its basic understanding. But with AI, it's probably going to start to learn what contractors do for regular installs and then be able to check against those standards that it's seeing in the model. So it'll be able to check out a model much better or faster, or actually find those real hits instead of the nuanced ones that really not a problem. They'll just fix in the field.
Well, I think we're going to wrap it there. Corey, I want to thank you so much for the time, and more importantly, the context and the depth of information. I think for our audiences today, as well as in the future, I'm going to, I'll extrapolate some information from today's live stream and share it out. I think there's a lot of value here. I think you serve your profession well, and you should be proud of it and how far along you've come.
Thank you.
I think you're a great example for how you can start off in one area, as you did as a draftsman, and really understand how to keep applying the education factors. And good for you and Piquette and Howard for bringing on these new tradespeople that will be able to use these technologies where they apply, and provide hopefully not just better financial outcomes for the general contractor, but also a better experience on the job.
Yeah, thank you for having me. It was great to talk about, and I'm very excited to see where VDC goes in the future, and its return on investment is clearly proven. So hopefully more people partake in it, because it will make everyone's job easier when we get there. So
for sure. Well, thank you again, Corey.
Thank you for having me. It was a great time talking to you.
All right. Take care.